Today we will study about the temperature inversion. See, while studying the atmosphere, you all would have a study about the normal lapse rate. Okay, so there we have studied that as you go up of the height, as you go increasing in the height, so what happens? Temperature decreases. So that is the lapse rate. So see here, how that lapse rate is taking place, that we can understand through the diagram also. So see here. Here I'll say, suppose this is our Earth surface. Okay. So in this Earth surface, what is happening? Now on our Earth surface, you know that we have the continental part. Then full mass of dust particles also there. Okay. So from the solar system, when the sunlight is coming, then after that it is radiating back. As it's radiating back, so here what is happening? Heat is going upwards. Okay, terrestrial radiation. And here in the down parts we have the full of solid particles. And as we go up, so what is happening? There in the atmosphere part, there is a decrease in these particles. Okay, so there what is happening? Since there is a decrease means what? Your temperature will be less. Okay, now here there is increase in means what? There are highly any space left between these particles. So here what is happening? High heating is happening at these places. Okay, and high heating happening is what? You all know that as the earth heat this place, so here what happens? Air descends. Okay, so here what will happen? So when it is heating our earth surface, and after terrestrial radiation is going back, so here what is happening? Here we have thick crust. Okay, and as up we go, so we have thin atmosphere. In the down parts we have thick atmosphere, and upper part we have the thin atmosphere. So there what will happen? There will be the less, means what, terrestrial radiation now it is going up long wave radiation. So here see, since all those particles are filled, okay, so here what will happen? There will be the large amount of heat energy absorption. Okay, so because of that only, here we will have the high temperature at the ground surface. And as we go up, so here what is happening? Now all those gap between the particles are decreasing. So that's why it is becoming the thin atmosphere. So there what is happening? Because of gap between those particles, so there will be only less amount of energy absorption. So because of that, what will happen? There will be less heating on this part. So now here some particles are there. Then again up as we go, so there will be some more gap between those particles. So here again the temperature will decrease. So in that way, temperature is decreasing as our terrestrial radiation is going back. So here temperature is decreasing. So this is our normal phenomena. So this particular normal phenomena in the troposphere part and down our atmosphere, that is known as the normal lapse rate. Okay, that is the normal lapse rate. Now what is happening? In the down part we have warm air. So normal lapse rate means what? Warm air. Then as we go up, we are having the cool air. So this is the normal lapse rate. Then what about the temperature inversion? So temperature inversion, that is the negative lapse rate. Okay, this is positive lapse rate. Normal lapse rate is positive, and temperature inversion is negative lapse rate. So here what is happening? As we going up the height, here the vice versa things are happening. Opposite things are happening. Means what? As we are going up the height, temperature is increasing. That you all can see in the stratosphere part. There, due to the observation of UV rays in the ozone part, so there heat is increasing in the stratosphere part. So that particular is known as the temperature inversion, because it is not following the normal phenomena. So see here, in this what will happen? Now this, since our temperature as we going up the height, so here what is temperature is decreasing. So we'll have the graph like this. Okay, and you all study that as you go up the height, there is a decrease of 6.5 degrees Celsius per kilometer. Okay, and now in this part, as we go up in our, you all would have seen the atmosphere. When we are studying about the structure of atmosphere, then their graphs you all would have seen. Here what is from the troposphere part, temperature decreasing, then it is becoming silent, then again when it is entering the stratosphere part, temperature increasing, then again it is stratopause is there, then after that what is happening, as we entering into the mesosphere, then we have the increase in temperature, decrease in temperature, then as we going into the ionosphere, so because of ion particles there is an increase in temperature. So we have the graph lines. So in the stratosphere part we have the temperature inversion, and in this part also we have the temperature inversion. So here what is happening, in the temperature inversion, in this part we have the cool air, okay, then in strato part we have the warm air. So by lysis phenomena you can easily guess that if you have cool air downwards and warm air we have upwards in the upper layer, then that is the temperature inversion. And in the normal lapse rate or the normal phenomena, as we have the warm air downwards and as it is going up the height, so we are finding the temperature decreasing, means what, cool air is blowing. So that is the normal lapse rate. Then now by these phenomena we can see that there are totally 4 types of inversion. So all these 4 types of inversion are surface inversion, upper air inversion, in that you all can see a stratosphere, and mechanical inversion. And that mechanical inversion, that we'll see how that is happening. Then we have the frontal inversion, then we have the valley inversion. So that valley inversion, all those inversions now we'll see in this part. See all those theory part, if you want to study that, everything are mentioned in the slide. So from there also you can study. And now all those understanding parts we'll do in our class. So see here, now in the normal condition, that is normal condition, normal phenomena, as we are going up, our earth is heating, then we have the terrestrial radiation, okay. So and here we have the less gap between the particles, here we have the large gap. So here what is happening, down we have the warm air, okay, due to terrestrial radiation. Then as it is going up the height, what is happening, there is a decrease in the temperature as we are going up the height, okay. And from upper part, okay, from the upper troposphere, from there cool air will be coming down. You all know that cool air descends and warm air ascends. So cool air will be coming down. Now in this part what will happen, when it is happening, so from downwards it is taking the dust particles also with it, okay. And in the middle we have the hygroscopic nuclei, okay, sorry, not dust particles, the dust particles, small dust particles or salt. So when our wind is blowing, so that time some small particles are settled up this part. So there what is happening, cool air is coming from this part and we have the warm air, and when it is taking the moisture with it, like from the water bodies, so all those water bodies, what will happen, they will get settled here in that on the dust. So their shape and size will start increasing, okay. Now from the upper part, see, actually warm air and cool air won't mix, okay, warm air and cool air won't mix. But here what is happening, here from the upwards cool air is coming, from downwards up air is going, okay. And here what is happening, on the dust particles, all those water droplets, all those moisture part, they are going and settling down here. So as we are going up the height, see here downwards we have the water body, so evaporation will take place. Now that water will become into gas part, liquid will become into the gas part, that will become water vapor. As we are going up the height, so here what is, temperature is decreasing, then that gas part will start melting and then it will change to liquid, okay. So here what will happen, all those on the hygroscopic nuclei, nuclei are, they are made up of, like you can say, as dust, salt particles, or all those ashes that during the burning, crop burning, all those ashes they are setting up down, or doing the, like you can see in the industry, smokes, all those everything, okay. So they are the hygroscopic nuclei, small particles, minute particles, okay. So on that this moisture will go there and it will get settled there, okay. Then slowly its shape increase. So here from the up this cool air is coming, now that air will get mixed into these parts, okay. So because of that only, as size increases of the hygroscopic nuclei, there we have the rainfall. So because of that we have the vertical mixing of warm air and cool air, okay. So that vertical mixing is the normal condition. So now at that time we will have the rainfall. And if we do not have the vertical mixing, then there would be no rainfall. So that means because of that only we are facing all those smoke, that are smokes during the winter season we are seeing that part. So that is because of temperature inversion. And remember, for temperature inversion there are some conditions. So that condition is should fulfill, then only there will be the temperature inversion. So for temperature inversion there should be winter season. Winter season is what? Like there should be temperature should be low and like there should be cooler area. Okay. Then there should be, now in this part we say there is a vertical mixing and that brings the unstable condition. Okay. So in this part, what is there in temperature inversion part? Here we should have the stable condition. That is very necessary. Stable condition we should have, and then we should have the winter season, means what, that cooler air should blow that side. So in this way temperature, in this part only temperature inversion will take place. And if we have the summer season, then there would be no winter, there would be no temperature inversion. Okay. So now see here. Now this is our normal part. See, now what is happening? Now suppose if we have the cool air this part. Now we during the winter season what will happen? You all know during the winter season we have the long night. So long night, like you can say that sun will set by 5 p.m. itself or earlier. Then sun will rise in the morning like 8 a.m. and if you come to the northern side then it might be like 9 a.m. So light it will rise. So the time gap between these parts, time gap, what is happening, like 14 hours, 15 hours. So one more condition you must know in this part is that winter season, then you should have a stable condition, then you should have longest time gap between the night and day. That means you should have the longest night. Okay. So longest night means what? Moon will be there. So from the moon we won't get any radiations. Okay. So during daytime only we will be having solar radiations. So here what is happening during the daytime, as it is radiation is falling down. So here there is the heating of our Earth surface. And during the night time what will happen? So there will be the heat loss. Okay. Now in this part, for understanding the temperature inversion, see here. Now during the winter season, what is happening? We have the less solar radiation, insolation. Okay. So during the night time, what is happening? Night time our Earth is getting cooled. So down parts we have the cool air. So here what is happening? Daytime when we had the sunlight, okay, and winter time what will happen? That warm will have the less density, so they will go upwards. Okay. And here what will happen? We have the only some amount of insolation during the winter season. So that time what will happen? There is the heat loss in the night time. So remember one more thing, there will be heat loss during the night time. So as there is a heat loss, so what will happen? This particular part will, warm air will be upwards. So heat loss is what? It will go near the greenhouse gases area or in the troposphere. So warm air will be going up. So in upper part we have the warm air, okay, because of heat loss, and down parts we have the cool air in the winter season. Okay. And remember that it will happen only if you have the longest night. And you all know that in winter season we have the long night. Okay. So when this phenomena comes, cool air, then after that upper part we have the warm air, then only temperature inversion will take place. Okay. So remember this one. And for the normal phenomena, that positive left side, there what will happen? We have the warm air, then as we go up we have the cool air. So that is the normal. So in this way temperature inversion takes place. Okay. Now see in this diagram. Here diagram what we have. Now in this part you know that when warm air is going up, okay, with it is carrying water from the moisture from the water bodies. So during that time what is happening? That all those moisture are getting settled down on the hygroscopic nuclei. So there we have, from the upper part we have the cool air coming down, descending down. So there we have the mixing of warm air and cool air. Okay. So that brings the unstable condition, and because of that unstable condition we have the rainfall. Now in the temperature inversion what is happening? we have the cool air downwards, and you all know that cool air descends, always descends. You all already I have taught you in the pressure base also that cool air always descends and warm air always ascends. Okay. Now see in this diagram. So here what is happening during the winter season, that also during the night time. Night time we have the cool air in the down part. So now we have the cool air, and that particular cool air will be descending. Okay. And then upper part we due to heat loss, that heat loss, that warm air we have in the upper part. So that upper part warm air, what will happen? That will ascend. You all know that warm air starts ascending. So that will ascend. So there will be no mixing. Okay. So there will be no mixing is what? It is bringing the normal stable condition. Okay. Now it is bringing a normal stable condition. So because of that, there will be no mixing of warm air and cool air, and there will be, then what will happen? All those particles settled in this atmosphere. Okay. All those particles settled in the atmosphere, hygroscopic nuclei particles, that dust, smoke, ashes. Okay. So they will be settling down. There will be no moisture on this part because of there is no mixing. So there what will happen? There will be a lack of rainfall because here hygroscopic nuclei means that smaller particles only. So during the winter season, why we are seeing smog? See, fog is a normal phenomenon. Okay, fog is a normal phenomenon, and because of industries, all vehicles, because of that we have the smoke, and all those smokes that they are going and mixing in the upper part. So there what is happening? Now see here, during the rainy season when it rains, so all those hygroscopic particles, okay, all those dust particles, salt particles, ashes, all those what will happen when it will rain, that time all those dust particles will come down and it will get settled on the land part. But here during the temperature inversion, what it is happening now, because of no moisture on this part, so what is happening? They will be suspending in the atmosphere lies only. Okay. So because of that only, all those smokes, again the pollution is increasing. So there will be all the smokes going up. They will be settling down in the upper atmosphere, troposphere. So there what is happening? There is only we have the hygroscopic nuclei, and that time what happening? They are not coming down. And in this rainy time when it will rain, so that time what, when all those particles will come down, then we have the clear sky. So you can see that immediately after the rainfall, you can see easily the clear sky, because there are no all those hygroscopic nuclei parts present in the atmosphere. So, and because of temperature inversion, there will be no rainfall. So there all those hygroscopic nuclei particles will be settling in the troposphere part. So because of that, there is like, if now this dust starts increasing, so there will be like blind part, you all can see, there will be darkness in that side. So because of that, during the winter season, we are seeing all those smoke, fog plus smoke, that is known as smog. So all those things we are seeing, that is because of temperature inversion. Okay. So all those dust particles, they won't come down. So because of that, we are not able to see a clear sky. So this is the part of temperature inversion. Now we saw about the different types of inversion, that is surface inversion. Then we have the upper air inversion. That upper air circulation inversion is also known as subsidence inversion. Then we have the frontal inversion. Then we have the valley inversion. So now you all would have a study about the temperature inversion. So now you all have understood about the temperature inversion. Now see in the other part. Now first we'll see about the surface inversion. So see in this surface inversion, now see what we saw, that for temperature inversion there should be the winter season, means what, cool air should be there. Then it should have long night. Okay. And also we studied that it should have long light, and it should have the stable condition, that mixing should not be there. Okay. And one more phenomena is that, remember this phenomena, because in UPSC they might ask that temperature inversion will take place in which condition, and during that time they will give the options like summer, winter, short day, long night, long day, short night. So light options will be there. So you must know all this phenomena. Now since this is a concept part, so you all will be easily you all will be able to recall all these parts easily. Okay. So now see in this part what is happening when in the unstable condition and in the normal phenomena, what is happening? We have the rainfall. So because of that we have a clear sky. Okay. Now in that part what is happening? Now moisture is going up and it is mixing. So because of that we have the cloud formation upwards. So when we have the cloud formation upwards, so there what will happen? Now that time we will have the darkness. Okay. So due to that darkness, after that when that becomes into a bigger clouds, so that time we will have the rainfall when they are not able to suspend themselves in the atmosphere. So for this temperature inversion, one more condition is that you should have the cloudless, means there should be no clouds. Okay. See, if formation of clouds will be taking place, then you would have the rainfall. Then we have the rainfall. That means all the sky will be clear. So that means there are no dust particles on the upper part. So that time we will be seeing all this the normal phenomena, normal condition, that lapse rate. So for the temperature inversion, all these four conditions are necessary. Okay. Now see what is surface inversion. We saw that during the daytime it is coming and settling down here, then we have the heat loss, and then warm air is going up. So we all know that cool air, and in the upper part we have the warm air, then there would be no mixing. So that is a part of inversion, temperature inversion. So now that heating of earth and terrestrial radiation. Okay. So that part creates the surface inversion. So on a flat surface we have that inversion, that is known as the surface inversion. So this is about the surface inversion, and we should have long night. Then now we will see the upper air inversion, that you also can say it as the upper air circulation. So now in this upper air inversion we have the two parts. One is the stratospherical part. So there what is happening? There we have the temperature inversion because of presence of ozone hole and UV rays coming from the solar surface. So because of that we have the heating of the troposphere part. So because of that we have the temperature inversion in that part. So that is a sphere in the atmosphere part. Okay. So that is one type of upper air inversion. Okay. So stratospheric inversion, that is one type. Then in another type we have the mechanical inversion. Okay. So that mechanical inversion, now we will study that one. So in this part what is happening? See here in this diagram we have the cooler air here downwards. Okay. And from the upper part also what is happening? Cool air is coming down, that is descending. Okay. Now here what is happening? Here we have the density high. Okay. Some particles like dust particles are there. Okay. So here we have somewhat density high. Now from here downwards also cool air is going that side. So what will happen? Here we have the mixing of same air. So because of that what will happen? Now that air in these parts what will happen? That density will become so heavy. So because of high density there will be the heat loss in this part. Okay. And due to that heat loss in this part, it will be releasing the warm air. Okay. Due to high density in this part, it will be start releasing warm air. And in the down part we have the cool air. So you all know that temperature inversion part means up of cool air we should have warm air. So that is the normal phenomena of temperature inversion. So now this phenomena is getting fulfilled. So now this particular phenomena is known as the mechanical inversion. So this, that without anything, any like on our surface phenomena or anything, this phenomena is taking place, that is known as the mechanical inversion. So this mechanical inversion is also known as the subsidence inversion. So remember this also, this is known as the subsidence inversion. And this upper air inversion, this particular inversion takes place mostly, see, all inversion will be taking place in the winter time only. Okay. And this upper air inversion, or you can say the mechanical inversion, what happens? That happens mostly in the mid-higher latitude area. Okay. Mid latitude and higher latitudes. And surface inversion we have, see, now in our country India also we have the surface inversion. So that surface inversion is happening in the tropical part. So that also you must know that. Now by the knowing the location of India, you can easily guess that our India is in the tropical part. So they are also in the northern India. If you see, we have the all those parts, smog parts like in New Delhi. So that is the part of India, and that our India is located in the tropical part. So surface inversion occurs in the mostly in the tropical part and also in the some parts of latitudinal areas. Okay, whereas upper air circulation happens mostly in the mid latitudinal area and the higher latitudinal area. Higher means what? You can go somewhat to the higher means you can go somewhat to the this part, like you can say in the temperate part. Okay, so in this area this particular phenomena happens. So in this, see, in this what happens, this can easily you can understand in the London part. So see, London we had a 7 to 10 days, you would have heard in the news that we had a skin cancer. There were skin cancer, and also there was lack of air because of this smoke. People were not able to breathe. Okay, so because of that people were dying. So that particular things, that mechanical inversion occurred in this London area. So London area comes in the mid latitudinal part. So by this you can know that upper air inversion happens in the mid latitudinal parts. Okay, so see here, now in this part what will happen? In this part density means air is going up and there will be no mixing. So what happens? All those dust particles, they will start increasing. Is what means we won't have any warm air. So because of that, during the winter season, what happens? We have the all those dust particles setting in that upper atmosphere. So because of that, what happens? We have to breathe that air only. So that of air mixed with the all those dust particles, that made all those people from the London side or the mid latitudinal side, there what happened? That led to the less breathing. Means they were not able to breathe those airs. So because of that, many persons died. So that London smog happened in the London smog that happened, that is known as the upper air inversion, and that place is located in mid latitudinal area. So that upper air inversion happens in the mid and higher latitude. Okay. Then next is about the frontal inversion. So see how front is created on all those fronts, that all those parts we'll study in the when we study about the cyclone, temperate cyclone. So there we'll study, and what is known as front, how it is here, that everything we'll study there. Okay. So now you see in this part, in this front part, what happens? As we all know that warm air ascends and cold air descends. So here what will happen? Wind, we have the horizontal direction. So in this part what will happen? As warm air coming from this side, suppose warm air is coming from this side, okay, cold air is coming from this side. So when both will meet, you can see when both will meet, warm air, cool air. So what will happen? Now cool air will subside, okay, and warm air will ascend. So here what will happen? Here this warm air after some it will become here and cool air will come here. So now here again the same phenomena, warm air and cool air. So now here temperature inversion will be taking place, and in this type of particular things are taking places. So here what will happen? Cold air must be down and warm air must be in the upward. So these particulars is known as the front. Okay. So cold air downwards and warm air upwards. So this particular is known as the front. So because of this, now this also is taking the place of inversion. So this front is also taking places. So because of that, it is known as the frontal inversion. And frontal inversion happens mostly in the mid latitude area. So remember this one, mid latitude area, tropical area. See, and mostly all those, see, temperature inversion we won't have in the coastal area. Why we won't have temperature inversion in coastal area? Because as we have the solar radiation, then that will be hitting the water, then there will be evaporation part, and when there will be evaporation part, that means air will be mixed with the moisture. So as it goes up, then there would be the formation of big clouds, then we will have the rainfall. So temperature inversion won't have in the coastal area. So remember this part. Then See, surface inversion happens in the subtropical area. We are in this tropical area that like 30-degree area. Okay, so that is known as the subtropical. So surface inversion in subtropical area. Then we had the upper air inversion, that is in a mid and higher latitude. Then frontal inversion, this mostly we have in the temperate part, that is mid latitude parts, and also you can say it in higher, but mostly it will be occurring in the mid latitude parts. Then we have the next part, that is known as the valley inversion. So see, yesterday we all study about the mountain bridge and valley bridge. So in this part, what it is happening? In this part, what is happening? See, during the winter season, okay, we all know that during the winter season we have the long night. Okay, suppose this is the mountain. Now see, upper part will be mountain, and this down part will be valley. Okay, so here what happens during the night time? So this during the winter season, this upper part will be cold. Okay, and this part will be warm. Okay, if this part will be cold, here this part will be warm because of day, all those solar radiations on this part. Okay, so now what will happen? You all know that cool air subside. Okay, they used to come down. Okay, now this is descending cool air, and now here cool air is descending from both the part, and this here we have the warm air, so it will start ascending. Okay, now in this part again we have the cool air, and then in upper part we have the warm air. So now there is the creation of inversion. So now this particular now from the valley we have the wind blowing. Okay, so that you all know that is the valley bridge. Okay, now this valley in this part, when we have this particular phenomena, so this is the valley inversion. So in the night time we have this type of inversion. So remember this one. So this is the valley inversion. So this is all about the different types of inversion. So you all can see. Now in this part we will study one more thing, that is you all would have got confused the katabatic and anabatic wind. Okay. Now see, when the air comes down, when the air blows downwards, okay, that particular is known as the katabatic, and when the air goes upwards, so that particular is known as the anabatic. So don't get confused. Anabatic means what? When it is going up, means what? Ascending air. Okay, and when it is descending, so that is the katabatic. And this katabatic and anabatic happens in the mountain and valley area only. So you must know all these parts. So now you all can see in the here all those inversions, about all those inversions I have mentioned. See, I have mentioned in these slides. Okay. So here see temperature inversion. So in the valley inversion, what will happen? That in the valley area when inversion is happening, so it is making the air denser in that down part. So there, because of all this, so in this you must remember that cool air should be downwards and warm air should be upwards. Then it will create the inversion, temperature inversion. So this you must know. So this is all about the inversion. So this is all about the inversion. Now you all must not get confused with this inversion part. Okay. So now this is all about the inversion. So any doubt in the inversion part? Any doubt in the inversion part? Okay. So just go through the slides. See, now we have studied all those inversion part, and also we have understood this part. So and already I have shared you the slides. So when you go home, just go through the slides, and there you study about this part. So okay, now let me share the other parts. That is, now temperature inversion we have finished. Now the next topic we will start, that is the clouds and its different types. Okay, are you all able to see the next slides, that is the cloud and its types? Anyone confirm me? Are you all able to see the slides of the clouds?
Yes, sir.
Okay. Someone confirm me whether you all are able to see the slides or not.
Yes, sir. We are seeing the slide.
Okay, some message in the chat. Message in the chat, because I am not able to hear you all. So message in the chat whether you all are able to see this next slides of the clouds or not. Okay, thank you. So I have got the confirmation. Okay, see here. Now we study about the temperature inversion. So now we'll start about the clouds and different types. So see, now from this part, what I will teach, just remember all those parts because this clouds part is very important. Clouds part, see, in each year, one or two questions are coming from this part. Okay. So now in this part, what is happening? They will ask for you the arranging those clouds. They'll give some clouds name and they'll ask for the arranging according to their size. And or somewhere like they might give some theory part and they would ask that which type of cloud is this. Okay. So now this part you all must understand all these parts. So see here. Now what is clouds? So cloud is a mass of minute water droplets, or you can say that tiny crystals of ice. So that is suspending in the atmosphere part. Okay. And now after it, when it is becoming heavy, that will come down as a rainfall. So that is a mass of minute water droplets. Okay. And that is formed by the condensation of the water vapor in free air at considerable elevations. Okay. So they are caused mainly by the adiabatic cooling of air. So that is low-ish dew point. Okay. Now see. Now we'll study about all those phenomena. So see here. Now in this part, we saw that in atmosphere we have like in our Earth surface we have daily movement of vehicles, industries. So because of that, dust particles we have dust particles, smaller minute particles, dust particles. Then we have the ashes. Then we have salt particles. Like when evaporation is having, so some less dense salt. So that also going in setting in atmosphere part. Then we have that the smoke parts. So all those parts, okay, they are suspending in the when they are suspending in the atmosphere part. Okay, all those minute particles. So all these particles are known as the hygroscopic nuclei. Okay. So if anyone asks what is hygroscopic nuclei, so don't get confused. So this is about the hygroscopic nuclei. Okay. So now in this cloud part, see in the while studying the clouds and rainfall, this hygroscopic nuclei is very important. Okay. So you must remember that what is hygroscopic nuclei. So now see here. Now for studying the clouds, now see. For this condition, one most important condition is the relative humidity. So relative humidity means what? That this relative humidity will be the 100%. Like see 100%, like from this diagram you all can understand how that is taking places. And I have mentioned the formula also in the next part. You can see. No, I think so. In the day for study classes, there you all would have seen the formula means what? Relative is what? Amount of that particular things present, then total amount that should be that limit of that particles should be present. So that is that percentage is known as the relative humidity. So see here, now from this part I'll teach you the relative humidity part. So see here, now for a rainfall you all must know that hygroscopic nuclei, that moistures are sitting down, that should be its relative humidity should be the 100%. So when it attains the 100%, that means it became saturation. Okay, and that when it attains the saturation part, then there will have the rainfall. So you must remember this. So for the cloud formation, relative humidity is very necessary. Okay. Now see what is the relative humidity. Now suppose if this is a particle. Okay. Now in this particle, this at 40 degree. Okay. Here in this water, that moisture capacity we have, moisture capacity that is there in this particle is like 750 milliliter. Okay. Whereas total capacity is 1250 ml. Okay. Or also you can, for easy understanding, you can take it as the 700 ml is there in this part. Now here temperature is 40 degree. That is there in that when atmosphere in the earth downward part. Okay, surface part. Okay, and its total capacity is the 1000 ml. Okay. Now you all know that if relative humidity is 100%, then it attains the saturation. Then we have the cloud formation. But here what is happening? Here we have only the 70%. Okay. So only 70% is there. So there will be no cloud formation. So how this will help in the cloud formation? Now see here. What will happen? Now you all know that warm air hitting this surface. Okay. And as it goes up, air cools down, temperature is decreasing. Okay, temperature is decreasing. So now these dust particles with the moisture. Okay, now when it is going up, okay, here is temperature is at the 40 degrees, temperature is 700 ml. Okay, now as we go up, temperature will decrease. Okay, now you can take the other particles that is at, like you can say it at 20 degree, and its full capacity is 700 ml. Okay, so this is fully 100%. Okay, now you can take this one. So this is full capacity this much. That means this is fully 100%. Now how much is there? See here. Now suppose this is going up. Okay, now in this part we have the 700 ml. As it is going up, what will happen? Temperature will be coming down. Okay, now as the temperature is coming down, okay, so now you know that limit of this particular is at the 20 degree, it is 700 ml. So as it is going down, as it is going up, temperature will be decreasing. So when this particular will attain the 20 degree, so there at that particular surface, what will happen? This particular nuclei will attain the 100% relative humidity. Then it will attain the saturation. Okay. Then because of that only it will get settled on those dust particles and there is a cloud formation. So this is about the relative humidity. So did you understand this part about this relative humidity? How that creation of clouds is happening? See, if that moisture it is not attaining the 100% saturation, then there would be no clouds creation. When it attains the 100% saturation, then there will be cloud creations. Then after there will be the mixing of all those clouds. Then that clouds will become bigger. Then we have the rainfall. Okay. So when it attains the saturation part, then we have the cloud formation. And then there we have the rainfall. So this is about the relative humidity. So okay. So now dew point. What is mean by dew point? So dew point means that the temperature at which that minute particles attains the saturation, or you can say that it attains the 100% relative humidity. So that particular temperature is known as the dew point. Okay. So at that temperature it is attaining the saturation, that particular is known as the dew point. So this also you must know. This is very necessary in understanding the rainfall. So this is about the dew point. Then this is about the relative humidity. Then see hygroscopic nuclei already we talked about that dust particles, aerosols, salt, ash, all those things present. And after it, when moisture from the downwards, when it is going up, that water evaporation are going up. So there it is settling down up of those dust particles. It is settling down, then size increasing. Then two clouds are joining, and then their size increasing. Then size increasing. So as the size increasing, it will be becoming heavier. So after some times, it will be like that. They will not able to suspend in the air. So in the atmosphere. So after that, what will happen? There will be the rainfall in all those areas where we have the cloud formation. Okay. So this is about the hygroscopic nuclei. So see, even about the cloud seeding, how those cloud seeding happen. So cloud seeding, you all must know that when we are adding silver iodide or potassium iodide, so this both are a salt. Okay, so you must know when we are adding silver iodide and potassium iodide. So remember about the silver iodide, both this iodide part, that this already there, it has been asked in the UPSC exams that how cloud seedlings happens. Okay, so that is artificial rainfall. So when in the atmosphere, when we add these particles, and we know that in this we have the moisture is going up, okay, and that up of moistures, if there are no presence of, sorry, we have the dust particles, okay, and this is the part of moisture. So when that gets settled down on this part, so their side will start increasing, then we have the artificial rainfall. So artificial rainfall we have due to the cloud seeding, that is because of adding of silver iodide or potassium iodide. So this is about the cloud seeding. So now see in this part, what is known as the condensation. So see here what is happening, as from downwards moisture is going upwards, okay, and they are getting settled down, they are getting settled on the part of hygroscopic nuclei, okay. So now here what is happening, as you go temperature decreasing, so that particulars they are getting settled down, and as you go that temperature is decreasing, so here what is this particle turn into ice. So okay, so when it will take the shape of solid part, that solid part or liquid part, okay, that after from the gas, that water vapor that is in gaseous state, so after from the gas as you go up, it will be taking the solid part or the liquid part, okay. So that particulars is known as the condensation. So this is about the condensation. Then now we'll come to the main part, that is the different types of clouds. So see here, in the different types of clouds, what will happen? So see, for understanding different types of clouds, so clouds are separated on the two types. One is the on the basis of height, okay, and another one is the on the basis of shape, okay. Now what is happening in this clouds pass, after some time you'll see that these both are mixing, and from there we have the different types of clouds name, okay. So see here, on the basis of clouds, on the basis of height, we have differentiated the different types of clouds. So see, from the lower part, from 0 to 2.5 kilometer, we have the strato, okay, that particular is the strato. Then in the middle 3 to 7 kilometer, we have the alto. Then in the height part, we have the cirrus. So how you all can remember that? We have one cirrus star, you all would have known. So that cirrus star is in the height part, so that is the highest, okay. So that will have the maximum height. So cirrus in the upper part, then in medium part. So medium means you all can guess by like middle class family. So middle class family, they won't be able to have those like a big like expensive cars like Range Rovers, or you can say that Audi. So they won't have those big cars, so those expensive cars. So middle family, what they'll have, they'll have the car of like Alto. So Alto, you all know that car. So that type of vehicles they will have. So by this, you all can remember that in the medium height we have the clouds, that is the Alto, okay, and in the low we have the strata, strato. This how you can remember that. In the earth crust we have the sedimentary rocks, okay. So sedimentary rocks means that we have the formation of strata layers. So that particular, that is the earth crust, so that is the downwards pass. So strato in this way you can remember. So on the basis of height we have the division of clouds, that is cirrus, that is the highest cloud. Then we have the alto, that is the middle cloud. Then we have the strata or strato, that is in the low cloud. And height is like 0 to 2.5 kilometer strato, then medium 3 to 7 kilometer alto, then at height 8 to 12 kilometer we have the cirrus clouds. So this is on the based on the size, sorry, based on the height. Now based on the shape, we have different types of clouds. So we have the stratus, okay. So stratus, these clouds, so stratus means what, you all know that, layers, okay. So this is layers. So here what will happen, clouds, these clouds will be in the formation of feather type. They will be looking the feather type, okay. So not in the feather type, they will be looking in the layers type, okay. So that layer you can see like that will be looking like feather type also. So that layer type, you know, the stratus, okay. Then we have the cumulus. So its shape will be looking like a cotton ball, and its here down part base will be the flat part. So you can say it like Also, you all would have seen a cauliflower. Okay. So this particular cauliflower we will study when we study about the cumulonimbus part. Okay. So that cotton wall, and in the down part base we have the flat. So that is the cumulus. Then nimbus is the rain bearing part. If we have the nimbus cloud in the atmosphere, then there will be confirmed rain. Okay. So this nimbus part is the rain bearing clouds. Okay. If there is no nimbus name added in the clouds part, then there would have no rainfall. Then there will be no rainfall from that clouds. And if name nimbus added is there, then there will be the rainfall, because nimbus is a rain bearing clouds. Okay. So this is based on the division of shape. Okay. Now we'll see about the cirrus clouds. So cirrus clouds means what? These are in the highest. Okay, these are in the highest. So here what will happen? In the cirrus clouds, what will happen as you go high? So that droplets, what will happen? Temperature will be decreasing. So they will turn into the ice. Okay, so height means temperature decreasing, so they will turn into the ice. So these cirrus clouds are composed of the icy crystals. Okay. Then cirrus clouds, what will happen? They have the fur and feathery appearance. Okay. So they have the fur and they have the feathery. So cirrus cloud have the feathery appearance. So cirrus clouds, you all can remember, this is division based on the shape. Okay. So don't get confused with the stratus cloud. Okay. That is based on the shape only, but in a stratus what will happen? We have the layers. Okay. So in a stratus we have the layers, and in the cirrus we have the feathery appearance. Okay. And then you all know that when it will be settling in the upward parts, and you know that ice, so fully that water will be there. So that cirrus clouds, that is in the transparent shape. Okay, it is transparent. Means there would be not that much of cloud creation, so there will be no darkness. So that is the transparent. So you must remember these three characteristics of cirrus cloud. One is it is fur and feathery appearance. Then we have it is composed of icy crystals. Then we have it is transparent. Then next cloud is cumulus. So cumulus you all studied that in the shape type. So there you all studied that it is like a cotton ball or flat base. Okay. So it will be that it will have the cotton ball and base will be the flat. Okay. And these, what will happen on this part, you can easily found the patches in the upper part. So characteristics is there are patches found in this cumulus cloud. Okay. And they are scattered. They are in the scattered type. Okay. Not settling down at one place. They are in the different type of scattered. Since they have the patches, so they are in the scattered type. Okay. So all those clouds mixing, they are taking a wall of cotton. Okay. And they have the flat base. So that is the cumulus cloud. Then next we have the stratus. So a stratus is what? Layer type. It will be forming the layer. So when it will be forming the layer means what? It will, from the down pass, it will be looking like sheet. Okay, like a thin sheet it will be looking. And this particular stratus will be below 3 kilometers. So this is the stratus cloud. Okay, and then next is the nimbus cloud. So when we have the nimbus cloud, that time what will happen? Our sky will be looking in the dark green color, and it will have the dense cloud. So this is the characteristics of the nimbus part. Okay, this is the characteristics of nimbus part. Now see, mostly we have rainfall. Okay, so see, in the upper part temperature is very low. So here what will happen? Here we have the icy parts. Okay, icy crystals will be there. So because of that icy crystals, there will be no melting, and there will be no hygroscopic nuclei formation. So there will be no cloud formation. So from this part we have hardly any rainfall. Okay, and in this mostly we have rainfall from the mid part, because hygroscopic nuclei are there in this part only, and that there is because of moisture carrying wind that is going and settling down there. So because we have the mostly rainfall from the middle part. So middle part means what? alto part. We have mostly rainfall from the alto part, and if nimbus is added, then only we have the rainfall. Remember this one. Okay. Then in low part, what will happen? That saturation for attending the, if they attend the saturation part, then only there will be the like relative humidity will be 100%. Then there will be the creation of all those clouds. Then there will be rainfall. But in down pass, temperature is not that much low to have the to attend those particles the saturation. So in the low part, we sometimes only little bit from this part we have the rainfall. Otherwise, mostly we have rainfall from the middle part. So you all must know about from the middle part we have the rainfall. So see here. Now we started 4 different types of clouds on the basis of height also saw, on the basis of shape also we saw. So on the basis of height and shape, there are 4 types of clouds: cirrus, cumulus, stratus, nimbus. Okay, don't get confused with this one. This part is not going to be asked. So sometimes means you'll think that then where's our alto is going. So don't get confused with this part. Only thing is that you must know the clouds, all those clouds names. Okay. So now see, now when you come to the next part, so about the all those cirrus clouds and cumulus cloud, nimbus, stratus, all those clouds, everything is mentioned. Okay. Now see here. So all those definitions. So nimbus clouds are black or dark gray. They form at the middle levels. So nimbus clouds are be mostly in the middle levels or very near to the surface of the earth. Okay. They are extreme dense and opaque. So there we saw that in the cirrus cloud they are transparent, but nimbus cloud are opaque. Okay. So you must remember this also. Then clouds are so low that they seems to touch the ground. Okay, nimbus clouds are shapeless masses of thick vapor. Okay, thick vapor you'll be seeing all those dark types. So they'll be looking in the dark gray color. Then this is about the stratus clouds. So all those clouds names here I have given. Okay, and study all those parts. Okay, low clouds, middle clouds, high clouds, because these clouds it would come in for the arranging according to height. Okay, arranging according to height. So you must remember that part. Okay. Okay. Now we'll move on to next part. So see, in the high clouds we have the cirrus, cirrostratus, cirrocumulus. Then in middle we have the alto. So cirrus means high clouds. If cirrus is added, then high clouds. Then alto means middle clouds, and if strato is added means low clouds. So stratocumulus, then nimbostratus, these are the low clouds. Okay. So now we'll see the other part. See here. Now cumulus and cumulonimbus, we have the formation. So this cumulus and cumulonimbus formation we'll see. First we'll see the different types of clouds, how those formation is happening. So see here in this part. Now see, here in the down parts we have the stratocumulus, stratus, and the cumulus. Okay. So yes, here we saw that cumulus means what? That will have the cotton ball shape type, and it will have the flat base. So this is the cumulus part. Okay. And see, cumulus part is also in the strato part. Okay. So strato means what? It is in the low part, 0 to 3 kilometers. Okay. Now stratus. So stratus, you know that strato. So that is in the lower part only. And stratus means what? It will be looking like a layers. Okay. So layers, it will be looking like a sheet. So when these both are joining, then we have the formation of stratocumulus cloud. Okay. So through this diagram, you can easily recall the understanding of the arranging the clouds based on their height. Okay. So in this part, you must know that cumulus comes in the low altitude area. Okay. And cirrus comes in the very highest altitude area. So suppose if in the exams these names are not given, by these names you can easily guess. So they are the part of that high part, middle part, or low part. Okay. And suppose that cirrocumulus is there, and also the cirrus name is there, then in the very highest part cirrus will come, then only cirrocumulus will come. So similarly in this part also, first cumulus will come, then only that stratus part will come. So you must remember that one if the name comes like that. Okay. So now see here. Now a stratocumulus part. So that is in the lower part, at the middle part. So we have the stratocumulus clouds. Then in the alto stratus, we saw the name of all those clouds. So in the alto, we have the altocumulus and also we have the alto stratus. So they are the middle part. So altocumulus, see here, pot and ball shape type is there. Okay, so this is the altocumulus. Okay, now see alto stratus, they are looking like layers. So here we have the alto stratus. Then cirrus, so cirrocumulus, all those small pot and balls are arranged. Okay, so they are cirrocumulus and we have the cirrus. And see how the formation of cumulonimbus happens. That also we'll see. So see all those clouds names I have mentioned in this part. Cirrus, cirrocumulus, cirrostratus, these are the high clouds, then middle clouds, altocumulus, altostratus, then the low clouds, cumulus, then stratus we have. So this is all about the different types of clouds. Now we'll see about the cumulonimbus cloud. Now see here, what will happen? See, mostly this cumulonimbus clouds will take formation. That shape it will happen in the water bodies area side only. Okay, so see here, water bodies, here what will happen? So mostly, sometimes it might be in the land area also or in the height area. Okay, so if we have the highest mountain side, so that side also that might be it will taking places. Okay, and height area means what? It should have the presence of water, then only it will happen. So see here, suppose if this is ocean. Okay, now what is happening? We have the radiation, incoming solar radiation. So when it is coming, it is going up, terrestrial radiation is going up. Okay, so now what will happen? Now this water will get warm, it will become into the water vapor. Okay, now it will become into gaseous state, it will go upwards. Okay, so in these parts what will happen? Now it will go up, it will get settled down here. Again that terrestrial radiation, what will happen? Now this is warm, so it will push these particles again upwards. Okay, then in the similar way this will push those particles in the upwards area. Okay, so what will happen as they go upwards? So what will happen? Now clouds will be settling down here, so they will start taking the shape of like a cauliflower. Okay, so from this part it will happen. So like a cauliflower shape it will start shaping, and its height will be keep on increasing. And after that, what will happen? How these cloud bursts are happening? So what will happen when those clouds don't have that much ability to suspend themselves with that much weight? So that time we have the bursting of that clouds. Then we have the rainfall, heavy rainfall. So that is the cloud burst. Okay. Then that particular what happens? See, this it is going upwards. Okay, and at its height is increasing. From here, terrestrial radiation come it push the clouds again upwards. Then again that radiation again it push the upwards. So it reach the maximum height. Okay, so there what will happen? There first some clouds will be formation will taking place, the smaller shape. Then that shape will start increasing. Then what will happen? That shape will start increasing, and then that shape will take place like a cauliflower. Okay, and that it will take a shape of cauliflower. And what will happen during that time? This cauliflower shape will be taking place in the, like you can see it that is a bigger shape. Okay, so when it's heavy weight, due to heavy weight and density, when it will be not able to suspend himself in the cloud part, so there after that there will be bursting of the clouds, and then there we have the suddenly rainfall. So that we have the cloud burst. So that particular the cauliflower shape is the cumulonimbus. And what will happen? From here we have the warm air. From this side warm air is going up. Okay, and from there cool air is coming down. Okay, so here what will happen? Here we have the meeting of those upward area, warm air, and downward cool air. So here when that point will meet, so at that particular point we have the thunderstorm, thundering and lightning. Okay, thundering and lightning. So remember that heavy thundering and lightning happens in the cumulonimbus cloud. Okay, and this cumulonimbus cloud is the highest cloud. Okay, so remember this part also. They will be between like 8 to 12 kilometers, like cirrus. Okay, So remember, this is a exceptional. Don't remember that cumulonimbus. So see in this, that according to height, it is not mentioned here. So that strato, then alto, that name is not mentioned. Okay. So here that cumulonimbus is like a up to the height of cirrus clouds. Okay. To that much height it will expand. So after that we have that when it will fall down, then there is a heavy rainfall. Okay. So during this time, due to that heavy rainfall, we have the thundering and lightning. So remember this property, thundering and lightning and the cauliflower shape. Okay. So don't get confused with that cotton ball shape. Okay. Cotton ball shape that we will find in the cumulus clouds. Okay. And cauliflower shape that we find the cumulonimbus shape, cumulonimbus clouds. And in these types of clouds, we have the thundering and lightning. Okay, so thundering and lightning and that cauliflower shaped clouds are known as the cumulonimbus. So by this part only, so this in this, when we have the tropical cyclone or cyclones, when we have the in the water bodies, so that there when we have the cyclones, means there will be like heavy wind is blowing, we have the heavy rainfall. So that rainfall is because of cumulonimbus cloud only. Okay, so remember this part. So during the cyclone, we have the bursting of cumulonimbus clouds. So this is about the cumulonimbus clouds. So, and remember all these properties. So this is all about the clouds part. So any doubt in clouds part? Wait a minute, let me, I think so volume is low, that's why I'm not able to hear you. So if you have any doubt, you can ask in the chat and let me change the volume. So any doubt in this clouds part? Anyone, any doubt in the clouds part, you can message in the chat. Okay, so see here, this is all about the clouds, and you all must know that low means we have the, so for remembering, for easy remembering, you know that low means we have the strato, then middle means we have alto, then in high means we have cirrus. Then based on the shape, we have cirrus, okay, that will looking like feather type. Okay, then we have the cumulus, that will looking like cotton ball shape. Then we have the strato, that will be in the layer type. Okay, then we have the nimbus, that is the rain bearing, means what, small droplets like clouds particles will be there. Okay, so small lights will be there. So that is about the different types of clouds. Now that the names are added and different types of clouds are formed, so by this way you can easily remember all those names of the clouds, and you all can easily be able to arrange those according to height, ascending order or in descending order. So in that way you can arrange all those types of clouds. So this is all about the clouds. So now in seeing this part, so cloud pass, so you must know all this and how it is happening. You must remember the hygroscopic nebulae also. So this is all about this part. So any doubt in this part, you can all ask for me. Now see, tomorrow I'll give it for today I'll give you homework. See what in this you all do. See, you all have to study about the precipitations. Okay, so this precipitation slides, I have mentioned all those parts. So what you all do, when you go home, just study the definition of all those precipitation points. Okay, so see, already I have shared the slides. So all those precipitation names are mentioned in that part. So there what you all do, just when you go, just see the definition of all those parts. Okay, so see here, like you see about this part, like precipitation, like fog, how it is happening. Then you already decide about the dew point. Then you all know that dew point, that is not part of precipitations, but dew point you must know. Then sleet, what you know the sleet. Then we have the like hailstorm coming down. We have the haze. So all those names are mentioned in the slides. So just when you have the free time, just like there is a small definitions only. So just go through all those definitions. Okay, different types of precipitations. Okay, so next class what will happen? So when we come tomorrow, we'll see about the precipitation. Then after that, we'll start the rainfall part. Okay. Then after that rainfall part, we'll start about the front, air masses and front. And then when we finish about the front, then there we'll study about the cyclones. So that will be the part of cyclones. Then little bit we'll see about the polar vortex. So that will be the part of climatology parts. Then we'll finish up our part of climatology. Then we'll move into the oceanography part. So that's all for this part. So that's all from this part. So any doubt is there, you all can ask from me. Otherwise, we'll end up our class, and tomorrow if you go at home and you study the slides, and if you have any doubt, then tomorrow at the starting of the class also you all can ask. So that's all for today. We'll finish up our class today at this point. Then tomorrow we'll try to finish at our maximum, because our time is coming nearer for the exams. So you have to do the revisions also. So you all start doing the revision from now on itself, and I will bring you all those PIQs question papers also. So that's all for today. Thank you everyone. Jai Hind.